So, hello everyone, welcome to Invent Model Technology Solution. And today is our first session of blockchain technology. So, today I'm going to give you a detailed introduction of blockchain technology, and we are going to cover some topics too. So, today's agenda is introduction to blockchain technology. Before moving to the content, we um, we can go through the course overview. So let's move to the course content. So this is our course content which we are going to cover in our this session of blockchain technology. So I will explain you one by one. So in first part we are going to cover the fundamentals of blockchain, which consist of some topics such as introduction to blockchain technology, basic concepts, types of blockchain, cryptography in blockchain, introduction to consensus mechanism, and we are going some into some detailed topic such as proof of work, proof of stake, and overview of blockchain platform, blockchain security basics, blockchain use across the industries. And the next part, which is intermediate part of blockchain concept, which consists of smart contracts, Solidity, programming language, where I'll show you how to make a smart contract using Solidity, developing smart contracts, advanced smart contract concepts, and introduction to decentralized application, which is also known as DApps, building of DApps with Ethereum, blockchain privacy and security techniques, blockchain in supply chain management, blockchain in finance, which is also known as DeFi, and the overview of blockchain regulation compliance. And in the third part, which is the advanced blockchain, we used to cover the topic like advanced solidity and smart contract, testing and deploying of smart contracts, Thorium 2.0, and scalability solution, blockchain interoperability, exporting different blockchain frameworks, decentralized autonomous organization, blockchain in healthcare, blockchain for identity management system, blockchain in Internet of Things, which is also known as IoT, blockchain scalability and future trends. In the last part, we are which is focused on the projects. So in the first class, we used to introduce our project and the idea and the design of the project, building and implementation of the project. So in next last classes are about finalizing the project presentation, and last class is wrap up class in which we conclude all the topics which we have previously taught to you. So these all are the content which we are going to which are going to come or which we are going to cover in this whole playlist. So today is the first day of this playlist. So let's start from the first part, and today is the class one or day one. So today we are going to cover the introduction to blockchain technology. What is blockchain? What is the detailed definition of blockchain? Key characteristics of blockchain such as decentralization, transparency, immutability, and security, history and evolution of blockchain. So let's start. So today's course content is detailed definition of blockchain, key characteristics, history and evolution of blockchain. So first we move to the definition of blockchain. So our first question is, what is blockchain? So blockchain is a decentralized digital ledger that securely, openly and irreversibly records transaction across numerous computers. Every transaction is combined into a block, which is then connected to other block is a chronological in a chronological sequence to create a chain. I will explain you what the terms written here. So blockchain is a decentralized network. Now, what is the meaning of decentralized? Decentralized means a type of system in which the data is divided into every nodes system, such as if we have a system, that this system only have the authority to manipulate the data, delete the data, create the data, whatever you can do from this particular system. But in decentralized system, one computer is not the owner of that particular data. Uh, Suppose we have 100 computers, so all 100 computers have the same data. If any data, if change in any data occurs, it will be visible on all the 100 computers. So it is impossible to uh, for mutation in any data, mutation or any change in data. So this is decentralized system, which is very secure. Obviously, if one small or minor change can be noticed by 100% or 100 computers, or we can say 100 nodes. So this data is obviously very secure, irreversible records. It means once a record is mentioned in the blockchain, it cannot be reversed. If you change the record, then it will add a new record that you have previously changed the data from this to this. Now you change from this to this. So data is record is irreversible. Every record has a block. In every transaction, we create a block, and a block stores the data and the changes, which can connect to other block in a chronological sequence to create a chain. It means one block is connected to second, second is connected to third, and third is connected to fourth. So this way is called a chronological sequence, which create a chain without requiring any central authority. No central authority is there, so no one can have the authority to manipulate the data. If data manipulation is occurs, it will be visible to everyone. It guarantees the security and integrity. So, if we can talk about the key components of blockchain, so the key components of blockchain are ledger, blocks, nodes, consensus mechanism, and cryptographic security. So, first we talk about ledger. What is a ledger? Ledger is essential digital blockchain is essentially a digital ledger that stores data across a network of computer. Blockchain always needs a ledger, which is used as a storage device to store the data in multiple computers known as the nodes in a particular network. Uh, Unlike traditional ledger maintained by a central authority, blockchain ledger is decentralized. It's shared among all the participants. Next is the block. Block consists of a series of blocks. Blockchain consists of a series of blocks. Each block contains a list of transactions, and each block has a unique identifier called cryptographic hash. Cryptographic hash is a unique code which is allotted to every block of a blockchain, and every block have a reference of its previous block or a hash of previous block. It concludes or uh, it holds the data of timestamp and the time and the data and the transaction record. Next is the node. Every individual computer in a blockchain network that maintains a validate ledger with that blockchain is a node. So every system which connected to a blockchain is known as a node or act as a node of a blockchain. Next key component is the consensus mechanism. For any transaction which have to be added in the blockchain, it must be validated by the network and participants in that blockchain. So for adding a new block in a blockchain, it must be validated by all its users. So if every user validates the block, then only the block can add to the blockchain. Otherwise, block not going to add in the blockchain. So let's move to the next topic, that is key characteristics of a blockchain technology. So first characteristic is there are basically four characteristics. First is decentralization, second is immutability, third is transparency, and fourth is security. These four are the basic building blocks of the blockchain. So decentralized means since blockchain relies on a dispersed network for their functioning. So it does not require any central authority to work. Next is the immutability. So data on a blockchain is permanent and impenetrable once it is recorded. So it means when that once data is recorded, it is permanent. No one can change or remove the data. Next is the transparency. On the account of transparency, we can say that accountability and trust are always maintained in the blockchain because every single change in the blockchain are available for the all network users. Everyone can see. Next is the security. Blockchain protects data against manipulation or unwanted access by using cryptographic mechanism. It means simply that no one can manipulate the data. If no one is able to manipulate the data, so simply data is very secure. If every transaction has a unique node, so everyone is able to find which changes happens at which time and who is going to change. So it have every detail about any change. So first we are going deep for these characteristics. So first we talk about decentralization. In traditional system, a centralized authority like bank or government manages a control over data or a transaction. But blockchain eliminates the need for such intermediates by distributing ledger across a network nodes or computer. Each node has a copy of entire blockchain. They work together to validate a transaction. This decentralized nature reduces the risk of single point of failure, ensures data integrity, and makes the system more uh, more reliable, and it saves from the attack or malfunctioning of the data. Second point is immutability. In immutability, it means no one can change the data. So, in concept form, we can say that once data is added to blockchain, it cannot be altered or deleted. This is immutability. It is enforced by the chronographic hash and the structure of the blockchain. Every block contains hash of previous block, creating a chain of data that difficult to tamper. If someone tries to change the data in a block, the hash will change, breaking the chain. This characteristic ensures that transactions are permanent and verifiable, makes the blockchain highly secure against the fraud and manipulation. Next is transparency. In blockchain, it allows all its participants in a network to view the same data, leading to a high degree of transparency. Every transaction is recorded on a public ledger that can be accessed by anyone within the network. While the data itself is transparent, users' identities are often protected using cryptographic techniques like public private keys. We talk about public and private keys in the next videos. So, and making the data anonymous but verifiable. This transparency builds trust in the system as participants can verify transactions without needing to rely on intermediates. Next is security. In today's era, security is very essential for everyone. So, blockchain security is rooted in its decentralized structure and cryptographic techniques. Since the ledger is maintained by numerous nodes, it's challenging for a single entity to alter the data. Cryptographic algorithms like hash and digital signatures ensures that transactions are secure and that participants can prove their identity without revealing sensitive information. Additionally, consensus mechanism like proof of work, proof of stake provides further security by requiring participants to contribute resources to validate their transaction. So I have covered all four topics and the key characteristics of the blockchain technology. Now we move to the history and evolution of the blockchain. So first is the conceptual foundation where we are going to know when the concept of blockchain come to the market or come to the knowledge of the people. Next is emerging of Bitcoin and blockchain. And there are some versions of blockchain such as digital currency, smart contract, and beyond the cryptocurrencies where Bitcoin is used, current and future trends of the blockchain. So first we talk about conceptual traditions. Blockchain's conceptual foundations date back to development of cryptographic technologies, an idea about decentralized system. During this period, key innovation in cryptography laid the groundwork for blockchain. This is the period of 1970 to 1980. Public key cryptography. This technology enables secure digital transaction and communications by creating a system of private and public keys. This would later become essential in blockchain for ensuring the integrity of the transaction. Next is the Merkle tree. Ralph Merkle invented Merkle tree, a data structure that allows efficient and secure verification of large amount of data. This idea would be used in blockchain to ensure data integrity. The next part is Hashcash and proof of work. Adam Back proposed Hashcash, a proof of work system designed to prevent spam by requiring computational efforts. This concept became crucial for Bitcoin security and mining processes. Now move to the emergence of Bitcoin and blockchain. First point is Bitcoin white paper. In 2008, on October 31, 2008, Satoshi Nakamoto published the white paper titled Bitcoin, a peer-to-peer electronic cash system, outlining the concept of decentralized digital cryptocurrency that solved double-step spending problems using blockchain. Next point is Genesis block. In January 2009, Nakamoto mined the first block or Genesis block, marking the launch of Bitcoin network. Bitcoin became the first real-world application of blockchain with its decentralized ledger and proof of work consensus mechanism, enabling peer-to-peer transaction without intermediaries. Next point is Bitcoin's early year. During this time, Bitcoin was primarily used by cryptography enthusiasts. In 2010, Bitcoin gained public attention when 10,000 Bitcoins were used to purchase two pizzas, marking the first real-world Bitcoin transaction. Its value began to rise and the first cryptography exchanges were established. Now we move to blockchain 1.0, digital currency. In this time, Bitcoin was primarily used by cryptography enthusiasts. In 2010, this period saw Bitcoin primarily being used to power cryptocurrencies, with Bitcoin leading the charge. Bitcoin's growth between the year 2010 to 2015. As Bitcoin popularity grows, alternative cryptocurrencies like altcoin, Litecoin, Ripple each bring different improvements. The blockchain itself was focused primarily on the enabling decentralized digital currencies. Now the challenges with the Bitcoin. As Bitcoin's network grow, scalability issue and the transaction delay become apparent highly secure. While highly secure, the proof of work consensus was resource intensive and slow, limiting Bitcoin's transaction throughput. Effort began to find solution for these limitations. Now people find the blockchain beyond the Bitcoin. During this time, developers and researchers began to explore the potential for Bitcoin to go beyond just digital currency. They began looking at how blockchain could be used for decentralized application and complex automated processes. Next is Bitcoin 2.0, smart contracts and Ethereum. The evolution of blockchain technology entered a new phase with the introduction of Ethereum, a platform designed to support not just digital currency but decentralized application and smart contract. First is the launch of Ethereum. In 2015, Vitalik Buterin introduced Ethereum, a new blockchain platform that enabled developer to build decentralized application, DApps, and deploy smart contracts. Smart contracts are the self-executing contracts with the term of agreement directly written into code, allowing automation of transaction and agreement without intermediaries. Blockchain adoption expands. Ethereum's flexibility lead to blockchain being used in a wide range of industry beyond just digital currency. Projects begin exploring applications like supply chain management, healthcare record, identity verification, and more. Now we move to the blockchain 3.0 beyond cryptocurrencies. Blockchain 3.0 refers to the stage where blockchain technology matured and began finding application outside the realm of cryptocurrency and finance. So, first point is enterprises blockchain solution. Corporation and industries began using blockchain for various use cases beyond finance, including supply chain transparency, healthcare, real estate, voting system, and digital identities. Companies like IBM, Microsoft, and Hyperledger started offering blockchain as a service, allowing business to easily integrate blockchain technology. Next is scalability solution. During this period, blockchain projects focus on solving their scalability problem through innovation like proof of stake for for Bitcoin and Plasma for Ethereum. These innovations aim to make blockchain more scalable, faster, and energy efficient. Now, it comes in the NFTs, non-fungible tokens. NFTs are digital asset representing ownership of a unique item like art, music, and virtual real estate become a major trend in 2020 and 2021. These tokens are primarily treated on Ethereum and marked as new culture interaction between blockchain and art. Now we talk about current and future trends. Central bank digital currencies. Government are exploring blockchain to issue central bank digital currency. Nations like China are leading with the digital yuan, and other countries are piloting CBDC to modernize their financial system. Next is sustainability and green blockchain. The environmental impact of proof of work blockchain has become a concern, leading to a push for more energy efficient alternatives. Ethereum's transition to proof of stake, Ethereum 2.0, and other eco friendly blockchain protocols are seen as a part of this shift. Regulations and the legal frameworks. As blockchain and cryptocurrencies grow, government and regulatory bodies are working to establish framework that ensures customers protection and anti-money laundering compliance and tax regulation while encouraging innovation. Web 3.0 and decentralized web. Blockchain is playing a pivot role in shaping Web 3.0, where decentralized application (DApps) replace centralized internet service, offering users more control over their data and online identities. So, this is all for today. I hope you like this video. So keep watching. We'll meet you. I will meet you in the next video. Thank you.